welcome everybody. I'm going to talk about digital twins for people, for personal assistants, which are, say, basically intended to help you without drawing a lot of the need to pay a lot of attention to them. So the idea is that they arrange things for you, not yet another app which you have to open up and put data in and things like that. I'm using digital twins to build them, and I will explain in my talk why I'm specifically using my kind of digital twins to do it. So if you look at digital twins mirror basically something that exists in reality, and the consensus about that is that you're going to mirror assets, resources, like in our case, persons, rooms, bicycles, parking spaces. You can. What's specific about what I'm doing is that I do the same thing with activities. So I'm not going to have some restrictive data model on how activities can be executed on an asset, associated and inserted into the asset. I have separate twins for activities. And this is where, of course, Elixir comes in, because activities are active. And if you want a piece of software that's also active, processes are very handy. Where my research becomes really interesting, but it's the advanced part, is that those activities have intentions. And because you have mirrors of what exists, you have mirrors of what's going to happen. If you have intentions, then you can mirror what is going to happen if those intentions are executed. That's the whole thing. And assets typically have policies. If you go to your doctor, he has a policy on how to delay you if the previous patient needs more time. What's specifically here is that our digital twins, of course, are much simpler than a digital twin of a car or an airplane of whatever. And so the focus in this development is more on the instances than on the types, on the experts in there. So twins mirror reality, and what's important about it is that you have to take advantage of the fact that reality is coherent and consistent. So you see on this picture, people probably don't like this reality, but it's coherent and consistent. So whatever happens, the world is in one state, whatever. If you have a pure twin, you don't intervene. You don't interfere, you follow. And why would you follow? First of all, to have this coverage of reality. If you're in an application and there are conflicts to be resolved because you're not developing from scratch, you're using things from everywhere, and designers have made choices. Those choices have a conflict. Some of those choices may have a conflict with your twins. Now, if the twin has a problem with other software, the other software has a problem with reality. So it's not the twin who needs to change. It's the other part which needs to change. That's the whole thing. Also, if you would, say, prevent your twin from tracking reality when reality becomes highly undesirable, so here, the car manufacturer say this does not happen to my car, so my twin doesn't track. Of course, the emergency services have no data to act upon. So never interfere, even if it's completely unwoke. You have a situation with humans, it's completely unwoke, but that's the reality. The twin part should follow the unwoke part. Because if you don't do it, you're not able to tell people that, hey, you're a little bit more unwoke than the majority, in order to have them shift to the other side. So this is the kind of things where you want your twin to be really non-interfering. Your corresponding reality consists of physical assets and activities and policies, and it's important to keep them separate, because if you, say, would have a monolithic version of what's an activity and an asset, then you get something with a small user group and a complex software artifact which is not sustainable. So that's important to keep them separate. The same thing is that for every twin, it's a very good idea to keep the expert part separate from the instance part. On a manufacturing conference, I have a difficult job explaining what the difference is between a type and an instance. Here, this is something I can just skip. But it's important that they're not in one monolithic element there. The user groups of expert modules, software, and the users group of management instances are completely different. So you can have lots of experts working with one kind of managers and vice versa. So second point, not enough time to go into deep in this one, is that you cannot build monolithic solutions. You always have to have composites, aggregations, and these aggregations will change over time. So if your real world changes, then your aggregate changes. And so if your structuring of your twins doesn't reflect how the real world is going to change, then basically your twin gets ripped into two pieces, and you can say redevelop and revalidate it completely. So the way you manage the relationship between your twins and reality is important. How do you implement it? Experts typically will be Elixir modules, whereas the managers, because they have to manage state, will be gen servers in my case. So it have to be processes, good practices in Elixir and Erlang is basically to default to gen servers, and you go to different things if necessary, but that's because a gen server is automatically supervisable, and you want supervisors to make things very robust. What's the relationship between this digital twin development, which you see, and then is hyped in some places, and AI, which is very much a hype at this moment? So one of the problems you have with AI is catastrophic breakdown. You have some analysis whether you're going to die or not, and then it tells you you're going to die, and it's not true, so they can go completely wrong. What you get with digital twins is that you can have AI applications which have a body and which are situated. So if you have to have an AI application about nuts and bolts, you get a very narrow target with high quality data, and you get a basic knowledge, which is hard-coded, about nuts and bolts, that the AI can never contradict or deviate from. So it's a much easier target, and the quality, especially the ability to let the AI do the job without having somebody to watch it, to see whether it's not going to bad in a very bad way, disappears. Second thing is that those twins are situated. So these nuts and bolts, the instances know where they are. If they are connecting an aircraft engine to an aircraft wing, they know the twin of the wing and of the engine. So basically, you don't need to handle things which are related to the others. You just delegate it to the other ones, and you can navigate. So if an aircraft crashes in Valckenaers because those bolts are faulty, you get to the twin of the faulty bolts, and you can start tracking whatever happened to them, because the instance of the aircraft will tell the history of flying. You can track the production of it and see which bolts have been produced with the same batch, and you can track the material twins to see what's going on there. So overall, digital twins, if you generalize them sufficiently, can have a huge application area in what we are doing. If you stick to the traditional view on it, that's a different thing. It will not be a huge impact. So why here? Why at the Beam or at Elixir? Is that by far this is the technology which has a small gap between the twins I want to build and the reality they have to mirror. Especially the instances if I need active elements and I want to build a counterpart in software, and I don't have the Beam, I don't have Elixir, I'm basically going to invent a data format which needs to be flexible, and I end up with something that's a very poor version of Elixir and the Beam anyway. I can have offline discussions about the issues of trying to have data modeling handle the real world instead of having conversations between active Elixir processes. Now, what's also a nice benefit of looking at twins is that the twin development, not the whole software development, can start before your user knows what he wants. So you can start developing your twins, and the only thing you need to know is what's relevant. And then you need to know more or less what the user wants to know what to develop first and what to develop second and what to develop maybe. You start with a tourist map, you go to a traffic map, and then in Portugal somebody would like to have the topology on there because they got a route to the restaurant which was running like this instead of like that. So But you don't need to know what people are going to use the twins or the maps for before you can start developing them. That's a key element there. And of course, you can develop before people who are thinking very hard. If this is implemented in such a way, this is going to change my life for the bad or the good. Huh? This is going to make my position in the organization weaker or longer. So the final user requirements discussions can be very painful, slow, changing, whereas the things you need to know to start your twins are outside this discussion, outside this dynamics, and it makes life easier. So what's important in your development in order to have your twins integrate across the world, basically, across the corresponding reality, is that you have a clean separation in your code between things that make decisions and things that mirror. So your twins are pure, and again, that's why you need a beam. You have decision-making interacting with twins and vice versa, and through twins. So it's not that they are operating independently. It's a real orchestration, a ballet they have to do. And you can have this because you have the beam, because you have these gen servers and things like that. So the decision-making is there. It's in separate modules. It's cleanly there. But executing-wise, they're all present. They're all active working there. And the thing is that your digital twin software can build up what they call software inertia, which means that if you change it, a lot of other things break. That's not a problem. You have twins, relying on twins and things like that. You have a tourist map. I have users of the tourist map. I change it into a traffic map. The old users don't break. They don't benefit from the traffic map, but they don't break. The decision-making is a totally different story. If you go to softwares which exist in the past and you want to integrate them, in the 5-day car project, they had SAP ERP system working with A and B, and with B and C, but the configurations of the software of the guy in between were incompatible, just because of incompatible choices. If there are conflicts with twins, there are conflicts with reality. So basically, it's okay. So I'm going to now switch to demos. I'm going to keep it to 1 probably then. All right, so here you have your frame, and so this is a typical thing. What you have is somebody plans the exams, and then when you have to do them, things don't go as planned. So you have to, again, the twins are not key on taking decisions. They're key on creating a situation awareness, which is good for the whole team in a way. So I'm going to get me some lectors. So now I have lectors. And, okay, this is me. But of course I didn't start the exams yet, so now I have to start the exams. And now I see my exams, and I used a different colleague of mine. She has 2 exams, so basically in there. And now if she has a problem with slot 2, for some reason she has an appointment with one of the kids, has a part there, then you introduce a number of the slot 2, and the twins of other lectors which are available on slot 2 indicate that they are available, and they also indicate the slots which they are, say, having exams themselves. So you basically can look whether it's possible to just switch duties instead of having somebody taking extra duties and the other one less, and then you have to compensate later on. But since you have twins, this is the kind of thing you can just add there. And then, of course, if you agree on changing things, then let's see here. Then basically, when my things get renewed, I have this new slot, and the colleague basically sees that the exam is gone. So the thing is that you have a situation awareness which is predictive, which can be refreshed up until the last moment, which is a full situation accounting for the interactions amongst everyone else. So this is what I'm doing here. Now I'm going to switch back to the presentation and finalize slideshow, current slide. Oh. Okay, so implementation-wise, we can discuss it. I'm not a guy used to be familiar with databases and web technologies. I'm coming from the Erlang part, so I simply have one live view page for every twin instance. You can have multiple mounts, so you can multiple tabs on the same thing, but they all talk to their own gen server, which accounts for synchronization. And in order to keep things robust, I apply the evaporate and refresh strategy. So you propagate the information, so the exam moments propagate to the lectors and the students they're supposed to have regularly that they're accounting there. And the students and the lectors have a kind of slower forgetting, so that if 3 refresh opportunities have passed and you didn't get a refresh, you just forget it. And you can, of course, arrange optimizations for fast response in that you explicit make the changes. But the point of reference has the right data, the reference data, and will keep on propagating it. So even if you make mistakes, if you have a special case which you missed out, because of the evaporate refresh, it just takes some time, seconds or whatever, for the system to be correct. All right, so that's what I wanted to talk, and thank you for your attention, and time for questions, I think.
Yes, thank you. All right, do we have questions? Yes.
Thank you.
I'll pass you the mic, it's easier.
I recently took a look at simulation options for digital twins and other kinds of simulations in general, like industrial simulations, et cetera. And so I see a lot of open source libraries in Python or Julia, or even things like engineers would use, like in MATLAB. And then on the commercial side, it looks like a lot of the really impressive 3D visualizations and simulations are done in C++ and things like that. So just, well, and the other aspect is, it seems over the last 20 years or so or more, to make it faster to build these simulations and to do this modeling of the digital twins, there are description languages. So do you think that there is a way to make it faster to build the kinds of simulations you're doing in Elixir?
Well, the thing to get it really going is the aggregation aspect in the whole story. So it should not be necessary for somebody who's building an engine or something like that to build simulations of all the engine components and the controls and everything. The digital twin of the nuts and bolts should be there, and you should be aggregating them. And if you have pure twins, you can aggregate them, because if they don't fit, then the reality doesn't fit as well. So that's the other part there. So that's what should speed things up. What there is a need for, but it's not done in industry at this very often, is you have these models which digital twins you use at the design stage and the engineering stage to make sure that the aircraft you're going to build is going to fly correctly. What they don't do is to have a single source of truth version of that can go with the device online during utilization. And if you take the 737 MAX, Boeing, it has been flying virtually before they start even making the first piece of it. But they have been making a digital twin of the controls of the trim surfaces as they would be implemented in the aircraft, which is a kind of PLC-like control things. And so they have a twin of that, probably the same code, which then virtually executes there. The problem is that in industry there is quite aggressive on territorial, and so the guys responsible for the trim could only access to one angle of attack sensor, and it malfunctioned, and the training on how to react to it was inadequate because of economic pressure, and 2 of those aircrafts have dived into the ground and people got killed. Now, so you build all the simulations, and aggregation is going to make it economical to do it, and then better as the main thing. And the Elixir framework, the orchestrator, is of course well suited to be the technology that brings everything together. But the other thing what you need is to have from the digital twins of physical and material laws to a digital twin of just attitude and altitude of the aircraft in this case, and you feed in all the information there. So not one single angle of attack sensor, but the 2 which the aircraft has. You have the inertial platform, you have the GPS, all those things come together, and they are sensor fused in the digital twin. And of course, they would immediately spot that this angle of attack sensor is wrong, and those people would have lived. So this is where you want to go. But say the effort of these quite complicated 3D models and then even moving of these things like that, it needs to be done anyway at some point. And if you start to have languages for that, the problem with anything that's a language, it's a complicated thing. So you need a large user group to make it alive. And those technical niche things never have those large user groups. And worse, even all the companies involved, like the Siemenses, are very much on vendor lock-in. So they even divide those small groups in smaller ones. So this kind of, if somebody invents a small language domain to do those things, I don't believe it. What I believe in is basically that if you make the models the right way, you can aggregate them. And so if you have to make a whole ship or aircraft of whatsoever, the nuts and bolts which are used everywhere, you can use that model as well. That's where I have to go. I don't think some magic thing on building twins as a niche technology has a real future. So that's my opinion.
All right, thank you. Do we have more questions? Going once? Okay.
Thanks for the talk. Sorry for my voice. I was wondering, so you're talking about really complex systems. I was wondering which area you envision digital twins will enter first.
Which ones will enter first?
Yeah, so like something small maybe?
Yeah, the thing is that the real breakthrough is when you have twins everywhere. So when everyone participates. But that's not where you can go first, because then you need everybody involved before you can start doing something. So I think like these exams and courses and things like that is something where you can start, because that's a closed society problem there. And then you mature it, and then they say, hey, but I also have to manage my kids, and I can use the same thing there. And then you're sitting in the airport, and it's bad weather and the storm, and you get no information, and say, hey, if there's twins there and there and there, I get all the time up-to-date information, and my twin can even arrange the consequences because of me being delayed with whoever is waiting for me and things like that. So it's going to. So these are twins for people. That's thing. If you look at smart cities, if you have twins of small roads and things like that, if you model there that somebody is cleaning the front of his building, and so the garbage truck will not be able to pass, and it will drive there virtually, then they will see it's not going to pass, and instead of discovering it and then having to back up and maybe crash some cars because it's small, they will simply be able to adjust the planning. So this, if you get it rolled out in full smart traffic, basically your traffic jams will move to home, work, and bistro, because your twins will basically see your driving, will discover that too many of you had the same idea, and then you have time to make decisions that will be using the twins in order to avoid these kind of things. But then, of course, everybody involved in the traffic needs to participate, otherwise it doesn't work. So that's not the first thing that's going to happen. In technical things, we demonstrated something like this in a factory at what they call technology readiness level 7. we call it production radar. So it was a 3D printing operation with like 100 machines. And they used this to predict when products would be ready for finishing, things like that. Where we had an airline implementation connected to their own MES system. They did it for the medical products because it was a bit easier to model the nesting for the propagation. That's because you can't do the full nesting while refreshing predictions. So you need something that's good enough to estimate what will fit in one machine in one go. But it's really a matter of getting something going that's small enough, and then people realizing, hey, this is how it works, and this could also be the students in the past. I used to give the mama papa taxi problem, which is basically called use this kind of things to make it so my meeting goes late, we can get my kids from school, and things like that. So this is I did a European project on the smart traffic thing, but the problem there is participation. So the way to deploy it would be starting with buses and bus lanes. And so if you have bus lanes, you lose capacity. And what you have is the ones who participate with the twin coordination get access to the remaining capacity. And because they participate, you really control how much is there, room is there, and you don't get congestion. So the traffic one was where we used the forward propagating of information of intentions with our mechanism, and we use traffic models to model the congestion back propagation. So the traffic people have nice models to model how congestion hits back. And if you are confident that you're using this system to avoid the traffic jam, the simple first order models are fine. So you don't need the second one with the waves, and then you don't need this one. Of course, if you're going to have congestion, then of course you can get these phenomena anyway. And then you have the model in which you can basically detect that you're going to be stuck there, and I not, because I go out before the problem is there, but in today I will be stuck because you go in front of me and you're queuing up and I'm queuing up and I can't get to the exit. This kind of optimizations, of course, you can do with twins, because if you have traffic things where people say cars have to talk to cars, then you have this audience problem. Your car is driving there, to which other cars should I be talking? If you have a twin of the infrastructure, you talk to the infrastructure and you can tell, I'm here or I will be there tomorrow at 3 o'clock. And anybody else who would also like to be there tomorrow at 3 o'clock knows he has to talk to you, and not to the million other cars which are there. So it's once it gets going, I see it getting faster and faster. But you're right, the first applications and then getting the success stories and things like that are what we need to look for. And I hope this kind of practical exam regulation organization, and I don't focus on the decisions, I focus on the situation awareness and on handling up until the last minute. So you have something where you could put in scripts to generate plans, and then have people change the plans, and then on reality, in the last phases, you basically are going to track people, and when something doesn't go according to plan, you see, you create a situation awareness, you create access to relevant data. So here, if I change things like that, when the room in which you have to organize the exams needs some specific facilities, chemistry or whatever, you're not going to switch rooms to a room which doesn't have these facilities. That's the kind of thing. So you allow people to make decisions, and all those things you need to know not to make a mistake or not to forget something. That's what's coming from the twins.
Okay. So once again, thank you, Paul.